Hello, I'm Angelika Żukowska, and today I'm going to go over my project. So this project is called Tools for Experimental Study of Algorithm for Finding the Second Hamiltonian Cycle. So let's go over the proposal overview. So what I want to do is to create tools for research regarding theoretical computer science problem, which produces the cubic Hamiltonian graph. And this graph always has an even number of cycles. There are only exponential algorithms for finding the second cycle, and Thomason's algorithm is one of those. It's one of CARS 21 and P-hard problems, and by my supervisors who made the alternating cycles exploration algorithm, I've been able to be inspired to make my own algorithm and see if I can improve it. I've done some various research and reading on this topic. My plan is to make an interactive visualization of the execution of Thomason's lollipop algorithm, and experiment with specific graphs and collect statistics in order to improve the running time. So Smith's theory led to Thomason's lollipop algorithm, and Kravchuk's family of graphs on 8n plus 2 vertices where n is bigger than 1. Then Cameron proved that Thomason's is exponential on the family of cubic graphs. And then Spirakis and Zamaraev showed us that the answer to does knowledge of the first Hamiltonian cycle C0 strictly help to reduce the running time of lollipop, and it does. Then we've seen Zong's reduction. And so let's go over to this analysis of my software. So I've made a web application where you have a selection of example graphs from other sources, input your own, and graph generator. And I've made some improvements to the time complexity of Thomason's inspired algorithm. And at first glance, it's quadratic time complexity, with worst case here being this, but going forwards to some more examples that I've tried, I believe them to be higher. However, quadratic is still pretty good, but is it too good to be true? Well, let's see. So here's the application structure. Now let's go to see what my final result will look like. We know that it's now a fully front-end solution in JavaScript and React. It completely omits the backend. So I've never made a project fully front-end before. This was a great challenge. I found React to be really difficult. I thought it was going to be the easiest out of React, Angular, and Vue, but it ended up the most difficult, but I think very rewarding. So let's see. Here we have it, folks. We have our source code within here, and we have the index.js, which is what we need to have at the beginning of this React app, and then we have an app.js, right? A lot of commented out code for now. And we have 4 sections here where we have experiments, we have the images used for the graphs, and we have pages and stats. So let's have a look at some things. We have checkbox that we've used, the one I've been really struggling with and not being able to finish yet. We have different experiments, right? So they're all basically the graphs that we have in the little fake database, and they're all, I will try to see how I can make this to be less repetitive, but there aren't that many examples, so it doesn't matter for now. Basically what we're doing is we're calling component callback. That's what I've learned long term about how to be able to pass from one component to another, so be able to pass from this little database to the visualization. And we have the graph generator. A lot of commented out for now. I might use it in the future, so for now I've just left it there. We have this state value, or handling change, where we're setting this value. And here again, we are using the callback. And okay, so this is the input your own where I was really struggling. And it's because this was the first thing that I really tried in React. And I had no idea how it works. And it seems so crazily complicated. For example, so we have this here, right? We're handling on change. No. This is for when we're just inputting the copy pasting. But here is when we input the vertex count, right? So, and then we produce the matrix. So let's go to matrix, right? Here, and what we have is we have vcount and set matrix, and on change function of the input, then what it does is it produces the matrix depending on what value was input. And after being able to even produce a matrix of tick boxes, which I also created, I had to somehow make sure every tick box has the row and column number. So we have xi and I here, which then makes the key. So I've been able to get this far, but now I still need to be able to pass in when it's ticked to another component. But because this was the first thing I've made, it just looks really crazily messed up. Why is it split here, right? For example, when you're calling input in here, why couldn't I just put this here, right? And then put all this inside of it. But you try it and suddenly it doesn't work. So, but it works when it's a separate function, so I'm not sure why, but yes, I've left it for now. I will still get back to it. that I just screenshot after I've rearranged, which I will also try to hopefully make it so that they can arrange themselves more nicely. Even circular, as I've done in Python, would be better than it is currently when it's just all over the place. So these are just really basic. I haven't input anything in there. But in Thomason, it's very full and there's too much in here. So I will need to expand some of the things into other files and so on. For now, it's how it is. So there's also, I was starting to work with these, but I haven't really touched up on them. So there's Hamiltonian cycle, which is the first cycle that it's ever found. It just uses this function. This is just an example that first time loads, and then there's also zeros. So it produces just a 1D matrix of zeros, then it can produce zeros 2D. At first circular cycle to adjacency matrix and so on. I've made the sleep function, which is the promise, but it really slowed down my work because before everything used to work instantaneously. All the results for every edge would just pop up instantaneously on the screen and that'd be it. But since I've put this in, for some reason, because when you set timeout, it suddenly puts it on the stack after it runs through everything else on the page, and for some reason it makes it slow even if you set it to 0. Even if the milliseconds are set to 0, suddenly it's slow. But I need to figure this out. So we have this visualization, which is the main component of the whole project. We have data, slow down, initialize speed. For now, ignore this part. This is completely not used right now. And we have, of course, the state, which everything is saved in the state if we want other components to use this. So when this experiment desk, this is input here, we assign this parent callback to this handle callback, and then it calls that method. So we have these things, these components here, and we then handle them. So we then set the state to be whatever we've passed in from those other pages, components. And here underneath these callbacks, we have all the buttons like play button and pause and so on. So if you play on slow down, it makes the speed be ×2, because speed is actually how many milliseconds you want to slow this down by. And the same for speed up. And then we can see that when you press start, play, what it does, it on click run on each edge. So when we've clicked this, it runs this function. So here we have it. It's an async function just because it needs to be if we want to use the await sleep in some moments, so we can visualize it instead of coloring it all just once. Just what last coloring would show then. So we first get the first Hamiltonian cycle and we run it per each edge. We first initialize the graph to be all gray links, and then we select an edge, and then what we do is we update the cycle to be in the order starting from that edge. Then we run black red to color that cycle black red, and everything else we color blue, and we find a new Hamiltonian cycle. And what it does, it follows the path, inputting in the iteration count to be 0 at first, and the 2 first edges, and true, where we follow the follow path. Right, so it's first color the first edge by first color, right? And then what we do is we go to the for loop where we color 2 edges. Well, so when it's even, we color it the first color, so black or red, and if it's not even, odd, then we color it blue. Or rather, we check for these 2 colors that we then follow through and add to our cycle. However, what I mentioned before was the data viz, which is a second graph, which would hopefully color it as we're following it rather than up front. We can rearrange it so that it looks the way we want it to. Hopefully, with some extra changes to the code, I will update this so it produces a nice visually graph the way we want it to. After we're running it, we can see all our different results, the iterations, and we have a little graph here, chart. I will add the labels to it and make it filled properly, and then we have the input your own. We can input our adjacency matrix, which then produces that graph. And after running it, we can see the results. The vertex count is the one that I've been struggling with. This is how far I've got with this. And then we have the graph generator. When we input a vertex count, it produces that graph, that cubic graph, and we can speed up and slow down options while displaying the results. Not too bad for it to take only 7.5 iterations for every single edge. There are actually many graphs that I've tried which produce half of the iterations of the vertices it has, so that's pretty great. But then again, on some graphs it does not work. I have some sort of bug and I need to find out what it is. After I added the space, so it works on more milliseconds, but now we can see it's nicely aligned with that space and it's working. Let's try another example, this time with 30 vertices. To do what I've planned to do is to make all this and then the experiments and start and slow down and so on. I've done these things. Stats, I've done some of it. I've not done these things yet, and not done comparison of different experiments together either. So that's my plan for the next steps, and improving everything else, improving the bugs, making sure it works on every example. For now it works on about, I'm not sure, either 2/3 of examples of graphs or 3/4, but it's looking very good, and I believe that I will be able to finish by the end and have it work nicely and improve on the generator with different patterns to be able to select it. And this is a great project and I like working on it. Hopefully I can manage to do something really great in the next few weeks. Thank you so much.